Hi everyone. Should I say morning, evening, and good afternoon? And my name is TOMOYA FUJITA. I'm here to present the Unix Domain Socket, and which is used for Aibot. And here's my agenda. I think it should be make it bigger. Big enough. So here's the agenda. So let me have some time for quick self-introduction and Aibot introduction. And after that, we can just jump on like actual topic. UDS is abbreviation, stands for Unix Domain Socket, ROS overview, and the UDSROS hands-on and QA. So who am I? My name is TOMOYA FUJITA from Sony Japan. I belong to R&D, Sony Corporation. And I used to work for the other company, like embedded firmware engineer for specific platform, working on MPEG audio stuff. And 2012, Unix operating system. So my background is really system programming, like virtualization, hypervisor, coherent memory interfaces, such kind of stuff. And after that, I got in this company, Sony, since 2016. And I'm working for the software engineer and architect and the robotics product development. And ROS and ROS2 system engineer, like middlewares, something like that. Okay. So let me explain why we picked the ROS for Aibot or Sony products. The ROS is I think everyone knows about this, but the common software framework for robotics and autonomous, including autonomous driving development. And we are positive that community activity is really good, and useful tools such as like debug, documents, and build tools or something like that. And the most important thing is a lot of packages already. So if we use ROS, we can just have a go. So that's an important thing for robots and the newest and the modern software framework and architectures. Okay, here is my work for ROS related work, which is I had the presentation last year, 2018 Roskam at Madrid. So if you want to, maybe you guys can take a look at it. Okay, so I get to say, in behalf of Sony all members, many thanks for the construct. Thank you very much for having me on this conference and the opportunity. So thank you very much. And I just want to thank you for everyone involved in this conference. And yeah, that's it. So let's go next. I have an introduction. Okay. So I think most of you are interested in robot. That's why you're here. So I don't need to explain that much. But what is Aibot? It's like Aibot is the dog robot, home entertainment robot, and it's an autonomous robot that brings us the emotional bond to you, like owners, and it's available in Japan and the US. Okay, this is exactly Aibot looks like. And the concept is really different. Aibot comes across to you and positive interaction to make with owners. So that's a whole new concept. The Aibot is always awake, and Aibot does not wake up command. Aibot does not wait for wake up commands, so it's not agent. So it just works around and gives you some love, like bonds between like owners. That's something that Aibot can do. And let me have some time to explain the Aibot platform. We use for application processor, we use the Qualcomm Snapdragon 820, the APQ1896. And on the left, you can see a bunch of sensors like two cameras, back and front face, and TOF, and touch sensors, microphone, PSD, the other stuff, including IMU. And on the right, we have dedicated motion processor to make the quick reaction to users. And we have our specific actuators, 22 actuators, directly connected to the motion processor. So we can have a real time with the motion processor. Okay, so the edge Aibot does the constantly and regularly does speech recognition and the source direction, and the feature camera to have wide angle for recognition, like a face recognition or something like that, and the local slam process. And commands available for dogs. It's not exactly the wake up command because Aibot is always awake. So, but something like usually dogs do, like a stay or something like that, Aibot can understand. And we have used the Sony DNN Deep Neural Network framework, which is on public already. So if you are interested in like AI programming, you can just look it up for it. And we have some system perspective. We have some boundary for ROS. So the body controller is ROS. So it's going to control the motion processor. But some other, like eye control or sound mixer is not exactly the ROS node, because we have to make the real-time quick reaction for eye and sound. So that is not the ROS node. So the Sony Robotics architecture is something like this. That's something we believe in the most of the robots. This is not only for Aibot, but the other robots we are working for. So on the left bottom, you can see the sensor. The device should have some sensors, physical sensor, to get some sensing data and to use it, the recognition and environmental, understanding. And if it has to, we can upload some data to the cloud, and it's going to process more like a intelligent processing, let's say the consideration or something like that. And we can bring it back that data to the edge and make some behavior planning, and we can actually make the action using actuators or something like that. This is really simple, and but I think it's sophisticated, the architecture for robots. So that's something we believe in for the most of the robots. Okay. So what is the problem for us for for our perspective? This information is already public. So the CPU consumption, the CPU consumption for Aibot, and lack of real-time latency and throughput. So next slide, I'm going to explain about that. Spend more time to explain Unix Domain Socket ROS overview. Okay, let's open chapter 3. Okay, so I know the conference should be working on the hands-on, but we will do that later. But before that, let me have some time to explain how it works for ROS transport overview, because it's necessary to my explanation. And okay, here is like on your left, the computation robot. ROS master is running on the left, and on the right, you can see the laptop to connect the display node. And it's all working, the ROS transport layer. And there are two types of connections. One is XMRPC, and this takes care of like configuration data, such as like who publishes which node publishes on which topic, or which subscribers on which topic, or something like that. This just takes care of like a configuration data. So this doesn't happen every single time. I mean, like when your system comes up online, if the configuration has been done, this doesn't happen a lot. So this is not important for us. So what's important for now is like TCP ROS and UDP ROS. This takes care of the user data payload. So actually, every single time you publish the data, or every single time you subscribe the data, this happens every single time. So this is exactly what we care for. So, okay. So this is just an overview. So we were focusing on like TCP ROS default. You use TCP ROS, and if you want to, you can use UDP. This is our focus here. So the idea is like just extend like TCP ROS with Unix Domain Socket if the connection is system inside. It's really simple. That's something what we did. So I add some software layer, OSI layers here. So if you use a TCP IP socket, you have to use transport and network layer, of course. But if you are using a Unix Domain Socket, you don't have to be down there. I mean, like a socket layer should be enough. So that's something we did. Okay. This is really common configuration on system A on the right, on the left, and system B is running on the right. And on system A, let's pay attention the blue direction. And even if the connection is system inside, without our Roskam, you have to use TCP IP socket anyway. There's nothing you can do. But with our fix, if the connection is system inside, let's say like a node C++ here, and a node Python RawSpice here, that should be connected with Unix Domain Socket, so we can detect that with IP addresses. So it's going to detect automatically. Okay, let's use Unix Domain Socket because this connection is system inside, so everything is done. So after that, the configuration is done. You use Unix Domain Socket, not a TCP ROS. So, but this is what we did is the hybrid system. So if the connection comes from the outside, let's say the red line comes from the system B node C++, and the system A node C++. This is actually like a connection that comes from the system outside. So in this case, it's gonna use TCP ROS as it is. So let's say it's a hybrid system, and this is everything it's done in our Roskam package. So actually, if you are working for the ROS application, I mean ROS nodes or ROS user, you don't have to know anything about this. All you have to do is rebuild the Roskam from our source code, and you have a go. That's everything is considered by API, and you don't have to care about that. But you can get high performance. Okay, so yeah, I already mentioned that no need to change single line of code for you. And the ROS C++ and the RawSpice is supported. And the source code is already open public. So if you want to, you can just click here and see you git pull to get the source code and rebuild your Katakin workspace, and you have a go. That's all you have to do, nothing else. Okay, so let's do some work here. Okay, I'm going to show you how much the Unix Domain Socket is better than TCP IP. And okay, let's make some directory and clone this inter-process communication benchmark. This is really, simple, the test program. So if you are interested, you can just take a look at it. So just make. Okay, and make run. That's all you have to do. And Unix Domain Socket and TCP IP and UDP IP, everything is done in this test program to check the latency and throughput. Okay, let's take a look at the here Unix Domain Socket. Okay, let's say 12 microseconds. But if we use TCP IP, that's 18. So like let's say 50% improved. And if we check on the throughput, Unix Domain Socket is 800 megabyte per sec. But if you use the TCP IP, 283. So that's okay. This is running in the cloud server, and you can imagine if this happens in the edge, like ARM64 or ARM32, that's going to be much faster. So that's the typical, the primitive like a performance improvement, just replacing the system inside connection using a Unix Domain Socket instead of TCP/IP. Okay, and we have done some like improvement test for ROS using ROS API, and we use Skylake for AMD 64 and High Keyboard ARM64, and yeah, so even if the ROS API, there is a lot of software stack on ROS, but we can still have some improvement. So yeah, so what we did is just replacing the Unix Domain Socket, like instead of TCP/IP, but it's much faster, and you can get good latency and a good throughput. But the point is, you don't have to change any single line of code for your application. Okay. Okay, let's go to chapter 4. Okay, let's do hands-on how to use it. Okay, it's really easy to use that because I already mentioned that all you have to do is just pull the source code and make. Okay. Oh, by the way, that first I want to do like build the Roskam because it's gonna take a little bit of time. So I don't want to waste your time on this conference. So just start building first. So yeah, source. Okay, let's do copy and paste. So we don't want any problems here. Okay, now we use the topic melodic branch. I used Ubuntu 18 and ROS melodic, so I just pulled the topic melodic branch. And it goes up Katokin workspace and Katokin. Yeah. So it's going to take a while, so let's keep working on the presentation. Okay, I want some. It's easy to use, but I need some time to explain like the modes which we support. So description is UDSROS is Roskam extension using a Unix Domain Socket for ROS message transmission layer, and yes, if the message transport is system inside use only, UDS Unix Domain Socket will be used automatically, and it's a hybrid system. I already mentioned that. And if the connection comes from the outside, it will use TCP/IP or UDP IP. You can choose it. And we have some socket mode for Unix Domain Socket. And the first one is the named socket. And if you use our Roskam, in default, you use named socket on temp, the file system. Temp is just temporary. In default, you use temp. We use the boost file system, so you can choose which directory you want to use. But in default, you can just use /temp, and the socket name will be based on the PID and suitable. This named socket is actually the based on the file system, so suitable if you want to control the file system permission. So using the named socket, you can control the topic. Like a subscriber or publisher, to give the permission to access. And another one is abstracted name socket. So if you want to use it, you have to set the environmental variable as below. So, but the socket name will be based on the UUID, and everything is done in kernel. So there's no files created in the file system. Okay, it's still building. The Roskam is like a huge package, like a meta package. I would say like 10 packages inside. So such as like a ROS master, ROS C++, RawSpice, or some other client libraries. So everything is building right now. So okay, one more thing is if you want to care about like performance, first, maybe you should use abstracted name socket. So there is no time, there is no need to parse the file. So everything is done kernel, so it should be much faster. And if you want to control the file access or the other stuff to see like actual files, the socket files, maybe you should use the name socket. But it's up to you. So you can just choose which one you want to use or which one is suitable for your use cases. Okay, I think it's gonna be done in a minute. Let's work. So first, we need okay, 97%. Okay, please give me one more minute to build the whole Roskam out. Oh, dismiss. Okay, it's almost done. So we are now what we are doing here is just rebuilding Roskam only. So the other packages like a ROS application, like a talker listener, which we will use on this hands-on, is nothing need to be changed. So only Roskam. We are gonna override Roskam with our own packages. All right. So let's run ROScore. So ROScore. Right, it's running now. And the second terminal. Okay. Let's use ROS C++. Really simple application, talker. Okay, so it's talking. And typical setup, push, and of course, listener. Okay, it's working. Of course, it is working. So let's check the Unix Domain Socket. So in default, we are using like named socket. So there should be socket files under /temp. So let's check on that. Okay. The top 6 files is created by our Roskam. So actually, this transmission is constructed and transmitted via these socket files using Unix Domain Socket. So this PID is talker and listener, and ROS out, I mean. So now actually it's working. Of course, this is connection system inside, so it's going to use the Unix Domain Socket. So okay, it's working using the named socket. So okay, that's an example. So let's stop. Okay, next is abstract named socket. For using that, we need this environmental setting. So ROS UDS ext feature 0x1 is needed. So let's 3 terminals. Okay, now they are aware to use abstract named socket. So the rest procedure is the same. Run ROScore, 1 terminal. terminal 1 and run talker terminal 2, and of course we run listener terminal 3. Okay, so it's running. Okay, let's check. Okay, there is. Oh, it's clear. Okay, there's no file for the socket, of course, because we use abstracted name socket. So let's check. Using a netstat. Okay. All right. There is a Unix Domain Socket here, listener and talker. So the socket name is constructed by UUID, so it's really magic word. So, but it's automatically created by kernel. So yeah, but it's connected. So this is actually running with abstract named socket. So if you are using an abstracted named socket, you don't have to care about the file system. So everything is down inside the kernel. So yeah, that's something like that. So not only for the topic, but also we support the service, of course. So let's do that. Let's stop everything. Okay, we already have done setting export ROS this environmental value. So we are not going to do it once again. So running ROS core. Okay. And the server. Okay, the point is we didn't change any application. We just reused the tutorials. Okay, the server is running. Okay, let's do some quick adds here. 1 plus 2. Okay, that returns the summary 3, which is correct. And you can see the server is constructed using a Unix Domain Socket. 2. You see that? Yes. The server is waiting to connect this Unix Domain Socket if the connection is system inside. Of course, you can access from the outside, system outside, using the TCP IP. But for now, it's just demo for using a Unix Domain Socket. So the server actually running a Unix Domain Socket and returns that value to the client. That's how it works. And it's not only for ROS C++. As I already mentioned, the RawSpice supported as well. Okay, let's stop server and the ROS core and unset. Let's use named socket at this time. Okay, the 3 terminals. We don't need this. Oh. And run ROS core once again. And let's run RawSpice tutorials, Talker Python. Okay. And let's run listener Python node. Okay, it's working. Yeah, there it is. Even if the RawSpice, there is a Unix Domain Socket. It's created temp file system, so it's working for ROS Python. And just in case, let's do the Python using abstract named socket. Okay, we want to stop that. Okay, everything we need is just export this variable. Now run ROS core and took a Python node and the listener Python node. Okay. So it's everything is working. This is using abstracted named socket. So ROS C++ and ROS Python, the service and the actions, everything is supported for our Roskam using Unix Domain Socket. I think the improvement is system inside only, but if you are running a lot of nodes inside of the system, I mean like services, actions, topics, it's worth for using our Roskam to make it faster or more throughput, even if the smaller your platform is, the more you can have. So that's really, like interesting. And what's more important now is you don't have to change any single line of code for your application. All you have to do is just pull our source code. Source code is for melodic and kinetic is ready. So if you're using kinetic, you can just pull some branch for kinetic and rebuild Roskam and override the packages with Roskam, new Roskam. So that's all you have to do. Everything is working inside and concealed by API, and that's everything you have to do. And you can have better performance. That's something we did for this Roskam, and it is actually used for Aibot. So let's say it's already out there with the product. So yeah, that's it.